Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 21. The question is, two identical non-conducting triangular plates, each of area A, carrying uniform positive charge plus 3Q and minus 2Q, are kept parallel to each other by inserting three identical insulating rods between their corners. Distance between the plates is much smaller than their linear dimensions. Assuming the assembly to be isolated from other bodies, find compressive forces developed in the rods. Let us solve this question. A, B, C is one plate, A dash, B dash, C dash is another plate. On A, B, C, the charge is plus 3Q uniformly distributed over it. On A dash, B dash, C dash, charge minus 2Q is uniformly distributed over it. These are the three rods, A dash, B dash, C dash. What is happening since the charges are opposite? So these plates will attract each other. But the rod A dash, B dash, and C dash is holding on the system in place. So it is not allowing the plate to move towards each other. So because of that, compressive force act on A dash rod, B dash rod, and C dash, and that we have to find out. Now because of A, B, C plate, since the gap is too small, much smaller than its linear dimension, we can say that the E field is equal to sigma by 2 epsilon naught because of ABC inside the area of between the plates, because of the plate ABC. So sigma will be 3Q charge is there and the area of this plate is given, so we can place that and we will be getting this equation for E. So how much force it will exert on plate A dash, B dash, C dash? If you multiply the modulus of charge with this E field, we will be getting the force acting on plate A dash, B dash, C dash. So we will get this equation 3Q square by epsilon naught A. In last view has been prepared here for you to understand and visualize easily. Since the plates are attracting each other, so these rods will come under compression. So compressive force will act on it. So if we consider the plate A dash, B dash, C dash and say that at A dash, FA dash force is acting and B dash, FB dash force is acting, and at C dash, FD, C dash force is acting on A dash, B dash, C dash plate. And we can show it like this. This cross mark is implying that the force acting on this A dash, B dash, C dash is perpendicular to the plane and it is inward to the plane. Means it is entering inside. Electrostatic force was the force of attraction between the plates, so that will be coming out of this plane perpendicularly. So that is why this has been shown as point here, pointing outwards and perpendicular to this plane, pointing inwards and perpendicular to this plane. And we have taken this perpendicular to plane unit vector, means in the direction of perpendicular to this plane inward side, unit vector as k. Since the plate does not have any movement or any acceleration, it is stable and in equilibrium. So it means FA dash plus FB dash plus FC dash will be equal to FE. And we also understand that the electrostatic force between the plate, that is Fe, will be acting through the centroid of the plate A dash, B dash, C dash. So O is the centroid. So we can get this FA prime, FB prime, and FC prime as Fe. Inward force is equal to outward force. So this is this. Please go through my write-up. I have detailed more in write-up for you guys to understand if you have not understand through the vocal what I am conveying, what I am trying to convey. Now, since it is a centroid and the position vector of this, we say that R1, this is R2, and this is R3. So we know from the definition that R1 plus R2 plus R3 will be equal to 0. So this is one of the equation. Another part is about this point O, there is no moment of force. So net moment of force is 0. So if we take the entire moment about the point O, we can write this R1 into FA prime. This is cross product. Huh? This is cross product. You can star mark, you can say that it is a cross product. So R1 cross FA dash, R2 cross FB dash, R3 cross FC dash. So this will be equal to 0. From 3 and 4, if you replace R3 by R1 plus R2 and simplify, we will be getting this equation, equation number 5. R1 plus R2 cross FA prime plus FB prime minus 2FC prime, and all are in the unit vector is K. This R1 plus R2, R1 and R2 is lying on the plane of the paper, and K is perpendicular to the plane of paper and it is pointing inwards. So in no case the cross product of R1 plus R2 cross K will be 0. So it means to satisfy this equation number 5, FA prime plus FB prime minus 2FC prime should be 0. So FC prime will be FA prime plus FB prime by 2. Similarly, we can do for, we will replace R2 in the terms of R1 and R3 and R1 in the terms of R2 and R3, and we will be getting FB prime is equal to FA prime plus FC prime by 2, FA prime is equal to FB prime plus FC prime by 2. So from all these equations 6, 7 and 8, you can conclude easily that FA prime is equal to FB prime is equal to FC prime. Now use equation of the electrostatic force we have got earlier, like 3q square by epsilon naught A. So FA dash plus FC, FB prime plus FC prime, these three was contributing to 3q square by epsilon naught. So one will be contributing 1/3 of that because all three are equal. So q square by epsilon naught A will be the final answer. I hope you understood the concept. It's a good question, and a lot of mathematics are involved. So go through the writer to understand easily. In case any doubt, please do let me know. Write in the comment box. I will appreciate that, and I will clarify that your doubt. And in the final, I'll request that please subscribe the channel so that it encourages me to give more and more problem in elaborative way of solving. And you can all your comment in the comment box is always welcome. Thank you.